Today we are going to talk about this interview question asked by all those tech companies. We are given the heads of two sorted linked lists, list 1 and list 2, and we need to merge the two lists into one sorted list. You can see the following example that we are given the list 1, 1, 2, 4, and the list 2, 1, 2, 3, 4. And we need to link all the nodes together to make sure they are in the sorted order. Next, I'm going to talk about the recursive approach. Let's denote ms as the merge sort recursive function. Inside the parameters, initially I put the head of list 1 and the head of list 2. So if list 1's value is equal to list 2's value, I can move either list 1 or list 2. I'm just going to move list 1 to the next, to the node 2, and I will change inside the parameter. I will change the list 1 to node 2 because we are moving to the next. So right now from the graph, we can ensure that the node 1 here is on the correct position in the sorted order. And the recursive function call, it covers all the portion of the graph here. So no matter how this recursion will return, which we will see it in the following, we can ensure that the node 1 is always correct. So we will link the list 1, which is list1.next, to this recursion. So now we are checking the list 1 and list 2. We know that list 1's value is greater than the list 2's value. So we need to move list 2 to the node 3 here. Now on this recursion level, we're looking for the graph that has this portion. Again, we are not sure about what will be returned from the base case, but we know that on here, the level 2, this is the optimum position. And if you're looking back for the previous recursive call, you can see that the node 1, it's actually linked to the node 1 here, and this is actually what we want. For the next recursive call, because 3 is greater than 2, so we need to move the list 1 to the next, which is node 4. Now, the node 4 is greater than 3, so we need to move node 2. And 4 is equal to 4, so I'm just going to move node 1. And this is actually our base case. As list 1 is reaching to none, we need to return list 2, which is the node 4 here. And the list 1.next, it's actually the last node of list 1 because of the previous recursion. So as the base case returning, which is node 4 from list 2, from list 1, it's actually linked to this node here. And the list 2.next, that means 3 links to 4. List 1.next, that means 2 links to 3. List 2.next, that means 1 links to 2. And then finally, we links all the nodes. The advantage of this approach is that the list 1 and list 2, the head is still on the head node. They are not actually moving to the end. So we can just simply return list 1 or list 2. And this is the Python code. We have the base case here, that if list 2 is none, that means we are at the end of the list 2, so we need to return list 1. Again, if list 1 is none, then we need to return list 2. During the recursion, we also need to return the corresponding list so that we can link all the nodes together. The time complexity of this question is O(n) plus n. N means the length of list 1, and then n means the length of list 2. And we have the optimum space complexity, which is O1, because we didn't create any variables. Alternatively, we can have the iterative approach, which is more straightforward. Initially, let's define two nodes that it's outside of the graph. So I'm just going to denote it as -1. We have the variable nodes called the previous. It is always moving, and it helps us to link all the nodes together. And the head of the previous, which is our final return answer. Let's go through the graph. Initially, we are on the head of list 1 and list 2. 1 is equal to 1, so I'm just going to move list 1 to the next. Now we need to link from the previous to the node by calling previous.next is equal to list 1. And the node 1 here becomes the previous because right now we are on this spot. So we need to move the variable nodes previous to the next on here by calling previous is equal to previous.next. And here's the Python code. You can continuously see how the algorithm works. Because 2 is greater than 1, so we move list 2 to the next. And we update previous next. We move the previous variable to here as well. 2 is less than 3, so we move to the next for list 1. And we link the previous next to node 2. And we update the previous. Eventually, you can see the moving variable previous links all the nodes together, and we just need to return the print head.next, which is on here. If you like this channel, please click like and subscribe. Thank you.